This is going to be the video for version number B for the quiz on sections 8.3 and 8.4. I have a separate video for version A of this quiz and the problems for that. So I'm going to start with number 1. So this is number 1 on version B. I have root 50 times x squared. So in a problem like this where you have both a constant and a variable underneath the square root, I like to separate them, break them up, and the product property of radicals allows me to break them apart. So now that that's done, I take a look at them separately. Well, on the right side, I'm in luck. It's an x to the second power. Anything to the second power you can cancel out with the power of 2 and the square root cancel themselves out. All I'm left here is with a simple x. The 50 is not a perfect square, so there is going to be a little bit more work, but not much, because the 50 can be broken down to the factors 25 and 2. And 25 is a perfect square. 25 is 5 squared. And I'm going to separate them out, the 25 and the 2, and so that way I can easily eliminate the power of 2 that the 5 has with the root. Again, that 5 squared came from 25 over here. So what I'm left with here is a 5 times root 2 times the x. All in all combined, that's 5x root 2. So that was number 1. I'm going to do number 2 now. So we have root 18 times root 2x. Now normally I would say simplify each individual radical separately and then combine them. And you could do that because the 18 is composed of the factors 9 and 2, and 9 is a perfect square. But if you look at this problem first and see what happens if you combine it, you will see that 18 times 2 is a 36, a bigger perfect square with no remainders. So in this case, while you could simplify this first and then combine them together, I'd say combine first is just going to make the problem simpler. So combining them, I get root 36x. I'm going to separate the constant and the variable. Not much I can do with the root x, so that's just going to stay that way. But the 36, I can break it down into 6 squared. And once again, I can cancel out square root and a power of 2. And when I do that, I end up with 6 root x. That's the answer, 6 times the root x. So that was 2. Let's go ahead and do 3. Number 3, we have underneath one big square root of fraction, x to the 5th divided by 36. And as we know, we can't have fractions underneath a square root. We've got to separate them out, which is exactly what I will do. On the bottom, perfect square, just like here, I'm not going to do the work. A root of 36 comes out to be a 6. So I'm going to write that down here. On the top, though, you have x to the 5th power, which is the same as x times x times x times x times x. Or you can write it as x squared times x to the 1st. As I told you before, anything with a power of 2 can and will cancel out its root and then hop out of the square root itself. So you're going to be left with x times root x all over 6. If you are to simplify this further, x squared, x times x, root x all over 6. And that is your answer. So that was number 3. Let's go ahead and move on into number 4. And I'm going a little quick because I need to talk under the 15-minute video limit. So I have 9 over root 11. Again, a fraction underneath the root, and just like last time, you are going to break these up into their own separate fractions. So root 9 over root 11. On the top, we're in luck. Perfect square. That's a 3 squared. Which means you can cancel out the power of 2 and the root. And be left with 3 over root 11. Now, some of you left this in this form on the quiz, and this isn't finished yet because you have a radical underneath the root, and you can't have that. You have to get rid of it. Now, how do we get rid of it? Well, it is a prime number. It doesn't really simplify into anything. We can multiply it by another fraction that's made of this. All by itself, root 11 over 11, root 11 over root of 11 is just a 1. Just like 2 over 2 is a 1, 3 over 3 is a 1. So essentially, I multiply this fraction by a 1, which doesn't change anything. You can multiply anything by 1. But what I'm going to do is I'm going to modify the problem. I'm going to modify it in a way that allows me to get rid of the root 11 on the bottom. So if I multiply across, I'll get 3 root 11 on the top and 11 squared underneath the square root on the bottom, because 11 times 11 once I combine it. And I just switch colors. The 11 to the power of 2 is going to cancel out its root, and you are going to end up with 3 root 11 all over 11. So again, all I did is I really modified the problem. I eliminated the root from the bottom and I kind of moved it to the top, essentially. While this may look, the problem might look like it's a little bit more complicated than before, it gets rid of our problem, which is a radical in the denominator, and that's the only way to do it. So that's the answer. And that's the important step. Alright, that was number 4. Let's move on to number 5, which is on the back. We have a very simple problem. So when you have a sum or a difference of radicals, you treat each particular radical as if it was a variable. Anything that has the same number underneath the radical, you can combine. Anything that has a different number under the radical, you can't. So it's combining like terms with variables. Same rules apply. So over here, you have a root 5, a root 5. Over here, you have a root 3 and a root 3. So those are like terms. So you're going to combine this and this, and then you're going to combine this and that. No problems. 3 root 5 plus 11 root 5, it's the same as 3x plus 11x in theory. So you are going to get 14 root 5. And then here you have negative 4 root 3 plus positive 2 root 3. So it's going to be a negative 2 root 3. And I apologize for noises in the background. There's a bio video going on next door. So that's the answer, with sound effects to boot. Sounds like something's dying. Alright, well, we're going to move on to number 6. That is a little disturbing. Alright, at any rate, so in here you have a problem like this. This is a power to the power type of a problem where you have an exponent that's external and an exponents that are internal, and you have to distribute the external exponent, multiply, by all of the internal exponents. And don't forget, So only two bases, one base and two base. So yeah, you just distribute the -2 to this base and -2 to that base. Once you do this, you end up with -2 times -2 is a +4. A lot of you wrote down -4. No. Multiply the two exponents, external and internal. -2 times -2 is a +4. Times 3 times -2. This is a negative exponent. Now anything that has a negative exponent, you have to switch it to positive, and the way you do that is you take its reciprocal or simply flip. If it's in the numerator, it goes into the denominator. If it's in the denominator, it goes into the numerator. So imagine this is all over 1, and this is going to now flip down. So you're going to get 2 to the 4th power on the top, because that didn't change, and m to the now positive 6th power over there, the there being the denominator. And the last thing that you need to do is simplify, and 2 to the 4th power, 2 times 2 is 4, times 2 is 8, times 2 is 16. And that is it. That's the answer to 6. Pretty simple. Last problem, 7, 3 to the -2 over x to the -5 times m to the 0 power. So similar to the last problem, minus the distribution plus something to the 0 power. So I just threw this in there to check for your understanding of anything to the 0 power. If you remember, anything to the 0 power is just 1. And that's about it. So that m to the 0 power kind of just disappears, melts away. But let's do the negatives first. So anything to the negative exponent, you have to turn positive by taking its reciprocal or simply flipping. So now to the numerator, it's going to go to the denominator. This is in the denominator, it's going to go to the numerator. And m to the 0, it's going to turn into a 1. And anything times a 1, is itself. So on the numerator, we now have x to the positive 5th power. And in the denominator, we now have 3 to the 2nd power, and m to the 0 power is just a 1. So the numerator doesn't change. The denominator is 3 times 3, 9, times 1 is still 9. And that is the answer to the last problem on the quiz for version B, section 8.3 and section 8.4. So best of luck on the retake if you're going to retake the quiz. Thank you.